In this video, we have this question on the board to solve, and it's an interesting question, because this problem now deals with a trigonometric function whose power is no longer 1. You see, if the power were to be 1, let's say cos theta, like that, you can integrate it directly using standard integral. Is that okay? But you see that this has a power. The way we handle this integral is in a special way. In fact, we need to use trigonometric identity. Before going into that, please let me show you something so that you don't get confused in case you mean that. Under differentiation, if this were to be differentiation, if you have cos squared theta, alright, you are to rewrite it as cos theta all squared. Then you now use your major minor differentiation concept. Differentiate from outside 2 times cos theta raised to power 2 minus 1, then times differentiate the minor, which is cos theta, and then if you differentiate, you get minus sine theta. That is quite different from doing integration of a trig function that has power 2 and above. Now you listen to this, please. If you can put it down better, if you are to integrate a trig function like sine or cos, where you have a power from 2 and above, not power 1, is that okay? You use a trig identity to solve that problem. Take note of that. So for this question, I was given integral from upper limit pi over 2 and then lower limit pi over 3 of cos squared theta, and to integrate with respect to theta, I don't know. So the first thing I need to do is to write the trig identity of cos squared theta. Now to do that, let me start by showing you something, alright? Cos 2 theta has a value, cos squared theta minus sine squared theta. Alright, minus sine squared theta. This is the value of cos 2 theta. So you see that from here, if I make a sine squared theta subject formula, it has a value to it. This will give me cos 2 theta is equal to cos squared theta. Alright, and then minus open bracket sine squared theta. We know that sine squared theta plus cos squared theta is equal to 1 from trig identity. Therefore, sine squared theta will be 1 minus cos squared theta. So I'm going to substitute here. Sine squared theta is 1 minus cos squared theta. Now work out this. Open up this bracket. You have minus 1 half plus cos squared theta. You will notice that cos 2 theta here, alright, will now be equal to, you open up this bracket, this will be cos squared theta plus cos squared theta, which is 2 cos squared theta minus 1. Now if I make cos squared theta subject to the formula, which is actually what I want to integrate here now, you will notice that this term will become, it implies that cos squared theta will be equal to, this minus 1 will cross to this place to give us 1 plus cos 2 theta. Then we're going to divide it by the coefficient of that cos squared theta, which I made subject of the formula. This term can still be written as cos squared theta has a trig identity of 1 over 2. There is a denominator 2 here, so you bring it out if you wish. It's a constant. Then you'll be left with 1 plus cos 2 theta. Take note, please, this one I brought out. It's not this one, alright? Okay, it's just the numerator of, say, this denominator 2 being brought out of this numerator term. So this is what we are going to use in solving this integral. Did you take note of something? I've been able to express cos square theta in terms of cos, where the power is 1, because this is cos 2 times theta. The power of this whole term is what? 1. And it's at this point we can now integrate. So I will now say it implies that integral from the lower limit of pi over 3 to pi over 2 of cos squared theta, the theta can still be written as integral from pi over 3 to pi over 2 of 1 all over 2 open bracket 1 plus cos 2 theta d theta. Alright, they're equivalent. So this is what I'll be integrating. Is that okay? Now 1 over 2 is a constant. You don't integrate constants, so we'll bring it out of the integral sign. This will be equal to 1 over 2 integral pi over 3 pi over 2 open bracket 1 plus cos 2 theta d theta. Good. Now the time has arrived for us to now integrate. So at this point we can now integrate. So this is 1 all over 2, then our square bracket, open up this with this integration sign and d theta. So we're going to have integral 1 d theta. It's the same as integral d theta, which will welcome back the variable theta. then plus, we'll come to this term, cos 2 theta. Just like saying cos 2x. If you are to integrate, you have to identify your major and minor function because you're going to use standard integral here. Okay, so this is your major, which is cos, and this is our minor 2 theta. So we're going to use integrate major function divided by differentiate minor function. You know, once you have any standard function, that's just what you do straight. So integral of cos, that is cos of a function, is the same as sine of that function. Then divided by, you differentiate the minor function 2 theta. If you differentiate 2 theta with respect to theta, you're going to get 2. Okay, so our limit is pi over 3 to pi over 2. Okay, we shall now substitute our limits. So this is 1 over 2. So we're going to have this. In place of this theta, I'll put upper limit. Then minus, in place of this theta, I'll put lower limit. So in place of this theta, I'll put pi over 2. So that's pi over 2 minus, substitute a lower limit, pi over 3. Then plus, come over here. This is sine 2 theta over 2. Now in place of this theta, you put pi over 2. Now if you do that, you're going to have sine 2 times, for this pi, that's for this theta rather, I'll put pi over 2. Then everything divided by 2 minus, once again, sine 2. In place of this theta, I'm going to put times pi over 3. Everything divided by what? 2. Close these brackets, then enclose all your brackets. So this is equivalent to 1 over 2. This term, if you work it out, the LCM here is what? 6. 6 divided by 2 is 3 times pi will give us 3 pi. Then 6 divided by 3 will give us 2 times pi will give us 2 pi. 3 pi minus 2 pi will give us pi. So this is pi over 6. Alright. Then plus, we're going to come to this term. This term is equal to 0. I'm going to tell you why. Under this 2, we cancel this 2. So let's do that. So 2 will divide this 2. You'll be left with sine pi. Sine pi is the same as sine 180. Sine 180 is 0. Is that okay? And 0 divided by 2 will give us 0. So I'm going to have 0, then minus, come over here. Now to work out this, sine 2 times pi over 3. Once pi is in front of a trig function, it's taken as 180 degrees. Is that okay? Because that is in radian, pi radian. So this is 2 times 180 divided by 3, which will give us sine 120 all over 2. Sine 120 from special triangle is equal to root 3 over 2. So I'll come over here and write root 3 over 2. Divide everything by this denominator 2. Is that okay? So this is equivalent to 1 over 2, open bracket, pi over 6. And then minus, this will give us root 3 all over. These two mathematically will come down to give us what? 4. Does that make sense? So we can now conclude this is the same as pi over 12. If you open up the brackets, these two will multiply the denominators, minus root 3 over 8. In conclusion, therefore, integral from lower limit of pi over 3 to upper limit of pi over 2 of the term cos squared theta d theta is equal to, our result is pi over 12 minus root 3 over 8. So this is the result. If you like, you can put square units. Now please take note of something here. At this point here, pi is not 180. Here, pi over 2 minus pi over 3, when we did this substitution, here the value of pi is not 180. In fact, it is 3.142 or 22 over 7. The reason, because this pi here is not in front of any trig function. It's not in front of any trigonometric function. But here, pi is taken as 180 degrees because it is in front of what? A trig function. Please don't forget that. Very, very important. Once again, do not forget how I handle this part, because this trig function is bearing a power which is more than 1. It's power 2 and above. So I had to introduce trig identity to reduce it to a term where the power of that trig function will be what? 1, before you start integrating. Let us look at this question we have here on the board to evaluate the integral x squared minus 3x plus 2 with respect to x under the limit 1 to 2. So have the lower limit to be 1 and then the upper limit to be what? 2. Now how do we solve this problem? It's pretty a simple one. The function f of x itself is a polynomial function, right? So in integrating, we have integral 1 to, that's integral from lower limit 1 to 2, then x squared minus 3x plus 2 dx. Now you know that to integrate this term, we are going to integrate each of the terms because of the plus and minus we have there, right? Good. So we'll integrate x squared. To integrate x squared, you're going to get x raised to the power 3 divided by 3. That is x cubed over 3. Add 1 to the power, divide by the what? Power. Then minus 3x. We integrate this 3x with respect to what? X. That 3 is a constant, so it will be kept constant. Then you integrate what? Your x there. Now if you integrate x, this is x raised to power 1, so add 1 to it, you get power 2 divided by that 2. So that will be 3 over 2 x squared. And then plus, this term is integral to dx. You know, we are integrating each of them. Now let me show you something. If you have integral to dx, these two will come out of the integrals and we know. So it will be integral dx. And you know that integral dx will welcome back the variable x. Is that okay? To welcome back the variable x. Which means that integral of this 2 dx, actually, it's going to be 2x. In one of our previous videos, we've already stated why this would welcome back the variable. Actually, what you're integrating here is x raised to the power 0. X raised to the power 0 is the same as 1. 1 times the x will give you the dx, so you are still mathematically correct. Now, if you have x raised to the power 0 to integrate, add 1 to that 0, you get x raised to the power 1 divided by 1, which will give you what? The x. That's what we mean by welcoming back the variable. Now we are done integrating successfully. We now have our lower and what? Upper limit. So what do we do with the lower and upper limit? We shall substitute for x here using upper limit minus lower limit. So I'm going to come here. Alright, this is going to be in place of this x, I'll substitute this upper limit 2. So it will be 2 raised to the power 3 minus, go back again, in place of this x, you substitute lower limit 1 raised to the power 3. We're going to divide it by what? 3. Okay? Now, if I wish, I will just put this in a bracket because I'll have to be done with it before I'll approach this minus. Then 3 over 2. In place of this x, I'm going to substitute upper limit, which is 2 raised to the power 2 of x. Then minus, go back again, in place of this x, I'll substitute lower limit, which is 1 raised to the power 2 that the x is bearing. I hope I'm making sense, right? Then come here, this 2 is constant, so plus 2, write it out. Then in place of this x, you put upper limit, which is 2. Go back again, in place of this x, you put lower limit, so minus 1. Our problem is as good as solved. So what is left is just normal simplification, alright? So let us simplify and see. 2 raised to the power 3 will give us 8. 8 minus 1 raised to the power 3 is 1. 8 minus 1 is 7. So this is 7 over 3 minus, if we come over here, 2 raised to the power 2 is 4. 1 raised to the power 2 is 1. 4 minus 1 is 3. 3 times this 3 will give us 9. So 9 over 2. Then plus 2 minus 1 will give us 1. 1 times 2 will give us what? 2. We have this term to work out its LCM. The LCM of this term is 6. So we're going to have 6 here. 6 divided by 3 will give us 2 times 7, which is 14. Then minus 2, 6 divided by 2 is 3. 3 times 9 will give us 27. Then plus, you know that this 2 is divided by 1. So it's going to be 6 divided by 1, which is 6 times 2. We have 12. Now this will give us what? Let's work around that. 14 plus 12 is going to be what? 26. 14 plus 12, 26. 26 minus this 27 will give us minus what? 1. Will give us minus 1. So minus 1 over 6. We are done. We can now conclude, therefore, integral with a limit 1 to 2 of x squared minus 3x plus 2 dx is equal to minus 1 over 6. And this is going to be our result. In fact, we should write this as square units, because in most cases when you're looking for integral of a term like this, it's actually area that you are calculating, alright? So this is the result of this integral.